everybody, I hope you're having a terrific day. In the last video, I tackled several major issues I had in the bilge. I used several techniques that were new to me, like fabricating with rigid closed cell foam and filling in a large void with expanding polyurethane foam. The new bilge is working out great so far, so I can check off another successful project. As I mentioned last time, as part of the process of prepping for work on the bilge, I had to disconnect the fuel lines and filtering system. I decided to empty out the diesel tank so that I was sure that no fuel would leak into the bilge and get in the way of my fiberglass prep and layup. Once the work on the bilge was complete, I decided to take a closer look at the tank as I was concerned about a few things. First off, the fuel supply was coming from a threaded nipple attached to the lower aft section of the tank. Since I had noticed what appeared to be fresh fuel on the outside of the nipple and the gate valves on the other end, it was obvious to me that some fuel was leaking from this connection. The more traditional method for fuel supply line is for there to be a pickup tube in the tank that comes up and attached to a fitting at the top of the tank. This does two things. First, there was no opening or fitting below the fuel tank that could leak. And secondly, by pulling fuel up from a pickup tube that sits just above the inside bottom of the tank, there is less chance for debris and gunk that tends to collect at the bottom of the tank to be sucked into the fuel line and cause issues down the road. On Le Maire, the tank sits in the area just forward of the bilge. I'm not sure if it's the original tank, but it was certainly custom made for this boat, as it fits like a glove inside this well. Even though the tank is made from stainless steel, there were several areas on the top of the tank that had some rust, mainly around some small plates that have been welded on. I assume that these were openings that a previous owner had decided to either close up or maybe as patches to previous leaks. In order to determine the integrity of the tank, I needed to pressure test it, and to do this, I wanted to take the tank out of the well. And surprisingly, this was fairly easy. I've heard horror stories from other boat owners about having to cut tanks in half while still in the boat in order to get them out of the companionway. My tank was small enough and light enough to handle and fit through the companionway with no problem. I set it in the cockpit so that I could inspect all of the sides and do the pressure test. After plugging up the fuel outlet on the bottom of the tank and the fuel fill and vent fittings, I then attached a 12-volt air pump that I had purchased at Harbor Freight to the fuel return line. From everything I've read, in order to properly test a tank, it needs to be filled with 3 pounds of air. This sounds like a very small amount, but as I was filling, I was sure that the tank was going to explode. I could see the top expanding and sections even popped up with a loud clang, but eventually I got it to the required 3 pounds. I then mixed some liquid dish soap and water into a spray bottle and sprayed the rusty areas on top of the tank, and sure enough, air bubbles quickly formed. Almost every rusted seam seemed to have a leak. I checked all of the other remaining corner welds, and they did seem to be solid. So my first thought was that maybe I would just have the old welds cut and new plates made and welded on. But upon further inspection, I saw lots of pitting along the edges of the tank. Now, while the pitting didn't pose an immediate issue, it was clear to me that I would ultimately have to replace the tank at some point. And the idea of investing money into temporary fixes on this tank didn't seem to make much sense. So I decided to research how much it would cost to replace the tank. As I was still unable to find any gainful employment, I was definitely concerned about spending a lot of money. I talked to a few friends that had replaced tanks on their boats and got the impression that it might not be such a huge expense. Of course, it would depend on what material the tank was made out of. My options were stainless steel, aluminum, and polyethylene, each having their pluses and minuses, but after many days of research and speaking with others, it seemed like the best option for me was an aluminum tank. Ideally, it would be great to have a tank made to fit exactly as the one that I pulled out, so I took very precise measurements and made a computer sketch, which I then sent out to several fabricators, some local, some across the country, and one even in Ensenada. Surprisingly, most of the people I reached out to did not even bother to return my calls, let alone provide an estimate. When I finally did get an estimate from a local vendor, it came in at around $2,700. I tweaked the specs a little bit to try to trim the cost down, but that only shaved off a few $100s. I ultimately received a quote from another vendor which was in the same price range, so it was clear to me that an ideal replacement was going to be out of my budget. I then started looking at prefab tanks that would fit into the existing well. Ultimately, I did find an 18-gallon aluminum tank for just over $300 from tankandbarrel.com. It included a fuel fill, vent, pickup tube, return, and a fuel gauge sensor. And at that price, it also included shipping. Now, under normal circumstances, these tanks usually ship in 1 or 2 weeks. The tanks aren't just sitting on a shelf ready to ship. They have to fabricate them from pre-cut parts in inventory. But due to the pandemic, the company had reduced their staff, so it took about 6 weeks for it to ship. I had also asked for a couple slight modifications, which one was to have the fuel fill and the vent fittings to be at 90 degrees versus straight up. So that may have added a little extra time. Now, while I waited for the tank to arrive, I did some prep work on the tank well and came up with a plan on how to install the rectangular tank in the V-shaped well. The plan was to build up a platform for the tank to sit on so that any water that would enter into the well would drain under the tank and aft into the newly reformatted bilge. In order to prevent any movement or deformation of the tank due to the force of fuel sloshing around inside, I would fiberglass walls to surround all sides of the tank. Now that I had a rough plan, I just needed to get the tank. Now, in the meantime, I worked on a few other projects, but you know what? I'm going to save those for the next and final video in my 2020 pandemic project series. When the tank finally arrived, I was anxious to get it installed. I dry fit it in the well and took some measurements, and then I was ready to start cutting and installing the pieces of the platform. The first piece was a center rail that was cut so that it was level fore and aft as the boat lay at rest. I put a bead of thickened epoxy on the bottom, then tabbed the sides with chop strand mat. Next, I added the 3 platform slats perpendicular to the center rail. Thickened epoxy was applied to the top of the center rail and to the sides of the slats where they rested on the hull. I also tabbed in the top edges of the slats to the hull and underneath where they connected to the rail. Once secure, I dry fit the side pieces and placed the tank in to make sure that everything was situated correctly. I then epoxy and tab the vertical edges of the side plates to the fore and aft bulkheads of the well, and then also to the top of the plates. After that fully cured, I applied 3 coats of Total Boat epoxy bilge paint to pretty much all of the platform, including the underneath section and the edges, inside edges of the limber holes. The tank has mounting tabs on the forward and aft ends. I bolted these through the platform plates. To make extra sure that the tank would not lift up under normal motion of the boat, I attached 2 strong rubber straps across the top. They can easily be removed if the tank ever needs to come out. Now that the tank was firmly in place, it was time to transfer the fuel that I had removed from the old tank into the new tank. To do this, I put together a pump and filter system to clean the fuel as it was being transferred from the 5-gallon buckets I used to store the diesel in. I purchased a diesel fuel lift pump, which I had wired to a 12-volt cigarette lighter adapter. I also purchased a knockoff version of a Raycor 500 filter housing. It was about $39, a fraction of the cost of the Raycor, and seems to be every bit as good. Now, once all of the fuel lines between the filter and the pump were attached, I connected the output hose of the pump into the return fitting on the fuel tank. The pickup hose was then lowered into the buckets one at a time until all the fuel was cleaned and transferred. The pump was pretty powerful, and it only took about 10 to 15 minutes to transfer all of the fuel. To be extra sure that the fuel was clean and free of water, I connected the pump and filter system to the tank via the supply and return fittings and let the system run for a couple hours to polish the fuel. Then it was just a matter of connecting the vent line and fuel supply line to the original Racor filter in the bilge, which then leads to the original fuel lift pump and engine. With everything back together, it was time to test the system. I started the engine and it pretty much fired right up. However, I did notice a slight surge of the engine at about every 8 seconds. At first I thought there might be air in the fuel line, but several attempts to purge air did not make any difference. Then I thought it might be the fuel lift pump. But then something was telling me that the issue was probably electrical, as I noticed that every time the engine surged, the DC meter on the ignition panel would surge to 14 volts. Then it dawned on me maybe it was the alternator. And sure enough, when I unplugged the alternator, the surge stopped and the engine ran smoothly. Turns out that the external voltage regulator had gone bad and was sending the voltage through the system at regular intervals. This extra voltage caused the fuel lift pump to surge at each interval. Fortunately, I had the original alternator that came with the engine as a spare, which has an internal regulator. Before installing, I took it to an alternator repair shop just to have it bench tested, and it checked out fine. So now it's installed and the engine runs smooth. Anyway, that's going to do it for this video. As mentioned earlier, I will do one more video in this series where I will quickly address a few of the last remaining projects I did in 2020. I've already begun tackling other projects here in 2021, so I'm looking forward to getting to a point where my videos are pretty concurrent with the projects that I'm doing. If you like this video, I'd really appreciate it if you gave it a thumbs up, and also feel free to leave a comment, as I am interested in knowing your thoughts and suggestions. And if you haven't done so, please subscribe to the channel and make sure to click the notification bell so you'll know when new videos are posted. Thanks for watching and have a great day. Cheers.